Hey everyone, welcome to this explainer. Today, we're diving straight into a project that is, frankly, a total game changer. We're going to build a complete, entirely subscription-free smart home safety system from the ground up using the ESP32 microcontroller. Whether you're a seasoned maker or, maybe you're an Arduino fan looking to finally make the jump to Wi-Fi, this one's for you. We're going to cover the whole shebang, wiring the hardware, writing the code, setting up instant Telegram alerts, and even spinning up a live local web dashboard.
Okay, so let's start with a pretty heavy question. If a gas leak started in your kitchen or a fire sparked in the garage right this very second, would you know about it? Would you find out before it's too late? It's a scary thought, right? But it absolutely grounds exactly why we're doing this today. Having a reliable safety system isn't just about showing off a cool weekend gadget, it is literally about genuine peace of mind.
So here's our roadmap for this explainer. We'll quickly look at the smart home problem, then meet our ESP32, wire up our safety sensors, write the code for those Telegram alerts, build out a local dashboard, and finally test the whole thing out.
All right, jumping right into Section 1, the smart home problem, commercial versus DIY.
Now, you just have to look at the sheer cost difference here. It's wild. Off-the-shelf commercial systems from the big brands, they can easily run you $200 to $500 right out of the gate. Plus, they hit you with $10 to $30 in subscription fees every single month. And the absolute kicker, if their cloud server goes down, your home safety system goes down with it. That's crazy. Contrast that with our DIY ESP32 setup, it's under $20 one time, zero monthly fees. It runs completely locally, and you actually own your own data. It's a no-brainer.
Moving on to Section 2, meet the ESP32, the MCU powerhouse.
If you've spent any time tinkering with electronics, you probably know and love the classic Arduino Uno. But check out these specs. This right here is exactly why we're upgrading to the ESP32 for this build. Right off the bat, we get built-in Wi-Fi and Bluetooth. We also get a massive leap in processing power, 240 megahertz of clock speed, and 520 kilobytes of RAM. Compare that to the Uno's tiny 2 kilobytes. For a smart home project where we're juggling data from multiple sensors, hosting a web page, and blasting out wireless alerts all at the exact same time, we absolutely need this extra horsepower.
All right, Section 3, wiring your safety sensors and connecting all the hardware together.
So here is your shopping list. You've got the ESP32 acting as the brain of the whole operation. To that, we're adding an MQ2 gas and smoke sensor, a PIR motion sensor to catch any intruders, and a DHT11 temperature and humidity sensor to watch out for rapidly rising heat. Throw in a loud, active buzzer for your audible alarm, plus a few LEDs and resistors just for some visual status indicators, and there's your full bill of materials. Like I said earlier, you can grab this entire pile of parts online for less than a $20 bill.
Let's talk about the MQ2 for a second. Think of this little guy as your home's digital nose. Inside, it has a tin dioxide sensing element. When the air is clean, this element has a really high electrical resistance. But the moment combustible gas molecules like propane or methane or smoke hit it, a chemical reaction happens that causes that resistance to plummet. That sudden drop in resistance sends a changing analog voltage straight to the ESP32, which basically tells our microcontroller exactly how much gas is in the air.
Now, before you go wiring everything up, I've got a crucial maker tip for you. The MQ2 physically has to heat up to do its job. It literally needs a 20 to 60 second warm-up period after you give it power to stabilize its readings. You absolutely must program a warm-up delay into your setup code. Trust me on this. If you skip it, that cold sensor is going to spit out wild, chaotic readings, and you'll be dealing with super frustrating false alarms the literal second you plug it in.
And while we're talking tips, please pay close attention to this wiring rule. The ESP32 has two sets of analog to digital converters, ADC1 and ADC2. Sounds great, right? Well, here's the catch. ADC2 actually shares its internal resources with the Wi-Fi module. So if you try to read your analog gas sensor on an ADC2 pin while your Wi-Fi is actively running, it is just going to fail. Hard. Always connect your analog sensors to the ADC1 pins. That's GPIOs 32 through 39. Seriously, remembering this little quirk will save you hours of pulling your hair out debugging.
Okay, Section 4, code and Telegram alerts. Let's get to those smart notifications.
So we're going to use Telegram for our alerts. Why? Because it's lightning fast, it's totally free, and honestly, it's surprisingly easy to integrate using the Universal Telegram bot library. Setting up your own bot is a breeze. You literally just open up your Telegram app, shoot a message to the official bot fodder account saying /new bot,
And boom, it generates a unique bot token for you. Next, you just message the user info bot to grab your personal chat ID. Once you've got those two little strings of text, you just drop them right into your Arduino IDE code, and that is it. Your ESP32 now has a direct, secure line straight to your pocket.
So what does this actually look like when things hit the fan? Well, if your MQ2 sensor spikes past a danger threshold that we set in the code, let's say we set the threshold at 700, the ESP32 instantly fires off this massive, unmissable notification right to your smartphone. No paid cloud subscription standing in the way, just an immediate life-saving alert. Oh, and you can easily throw some cooldown logic into the code too, so it doesn't just spam your phone with 100 messages a second while the alarm is going off.
Moving on to Section 5, the local web dashboard, your very own command center.
Now, Telegram is fantastic for when you're out of the house. But what if you're chilling on the couch and just want to glance at your home's vitals? Well, the ESP32 is actually beefy enough to host its own lightweight HTML web page. You literally just type its local IP address right into your phone or laptop's browser. This neat little dashboard auto-refreshes every 5 seconds, giving you live temp and humidity readings, a slick visual bar showing the current gas levels, motion sensor status, and even a log of recent alerts. And the best part? Because this is hosted 100% locally on your own Wi-Fi router, you can securely pull up all these stats even if your neighborhood's internet connection goes entirely dark.
Finally, Section 6, testing and next steps. Time to prove this thing actually works.
Listen, you never ever want to wait for a real, actual emergency to find out if you made a typo in your code. Safely simulating these threats is an absolute must. To test the MQ2, you can just release a little bit of gas from an unlit lighter right near the sensor. For the PIR Motion Sensor, just walk past it from, say, 3 meters away. And to simulate the rising heat of a fire, grab a hairdryer and gently aim it at the DHT11. Walking through these steps ensures that your buzzer, your blinking LEDs, and those Telegram alerts are all firing exactly the way they're supposed to.
And just like that, we've reached the end of the explainer. You now possess the blueprint to build a highly capable, completely custom smart home safety system. But you know the beauty of maker culture, right? A project is literally never finished. The ESP32 platform has so much room to grow. So, what's your next move? Are you going to snap on an ESP32 cam module so you actually get a photo texted to you when motion is triggered? Or maybe wire in a lithium battery backup so your whole security grid stays online during a blackout? The power, the code, and the choices are totally in your hands. Get out there, have fun building, and above all, stay safe.